All right, I've pre-drawn an angle in standard position. The angle is right here. I'll call that angle theta. Okay, and it's this going up there. Perfectly nice angle. Vertex here. Positive x-axis is its start, and I rotated to go up here, or maybe I rotated around that way. It doesn't really matter. Somehow or other I got to this terminal side. Now one of the points on the terminal side is a point 68. Okay, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So the terminal side of this angle in standard position passes through the point 6, 8. And I'd like to know, what are all the 6 trig functions? Okay, so I obviously touched that and rubbed that out. This is supposed to be cosecant. Cosecant theta. All right, so let's see. If I have a right triangle, I know I can use SOHCAHTOA. Well, let's make a reference triangle. And a reference triangle is always made to the x-axis. I'd be acting this out if we were in the classroom. I'd be standing here and I'd be waving my hand up and down, making a wing here. I go to the x-axis. Well, here's the x-axis. So I go down to the x-axis to make a reference triangle. All right, a reference triangle. So this is x over and y up, isn't it? So this is 6 to the right and 8 up. Well, how can I find that missing piece? The Pythagorean theorem. X squared plus y squared equals r squared. While we're at it, this is actually the equation of the circle with the center at the origin. And if this is r, could you imagine I could spin this around? And I would get a circle. If I spun it perfectly, I'd get a circle. So this could be the radius. I'm going to refer to that as r. The reason for that is because it could be a radius of a circle. So that's r squared. So r is my missing piece here. Well, x squared is 6 squared, so that's 36. Y squared is 64. And 36 and 64 is 100. So r squared is 100. So that makes r what? That's an r squared. That makes r 10. So this is 10 out there. Okay, then I can use my SOHCAHTOA right on this. Sine, here's theta. This is the angle theta. Sine is opposite over hypotenuse, so the sine is 8 over 10, which would reduce to 4 over 5. Cosine, ka, adjacent over hypotenuse, that's 6 over 10, which would reduce to 3 over 5. TOA, tangent, opposite over adjacent, that would be 8 over 6, which would reduce to 4 over 3. Then these three are easy once I have those. The cosecant is 5 over 4, the secant is 5 over 3, and the cotangent is 3 over 4. Okay, so far easy. But that point's not going to be always there in that section. That point's going to move. It's going to be someplace else. So I need to have a different definition for my sine, cosine, and tangent. Right now I know I can find them, but let's get these numbers out of here. And let's get a new definition. I'm going to replace my 6, 8, and 10 with x, y, and r. So this is x over, y up, r out. So that means the sine, so opposite over hypotenuse, the sine is y over r. The cosine, ka, adjacent over hypotenuse, is x over r. The tangent, TOA, is opposite over adjacent. It's y over x. So then these three are r over y, r over x, and x over y. And these are the Cartesian plane. See, that's an A. Plane definitions. The Cartesian plane definitions. You have to memorize them. You need to know them the same way that you know SOHCAHTOA. You need to now know sine is y over r, cosine is x over r, tangent is y over x, cosecant r over y, secant r over x, cotangent, I kind of rubbed that out, that says cotangent here, C-O-T. Cotangent theta is x over y. Memorize, memorize, memorize. I'm going back on with another video to show you different quadrants and why these definitions work.